In this video, we're going to learn how to perform some operations with complex numbers. We're going to start off with just simply adding and subtracting. And although we have our complex numbers involved, and recall I is our imaginary number here, making this a complex expression. Whenever we're adding these two, I've got a complex number plus another complex number. It's really just like combining like terms. So whenever I do that, we can add our two constants. So I have 3 plus negative 2, which would become a 1. And then I have negative 4i plus 6i. And that's going to become a positive 2i. And then really this is as simple as your expression gets. So basically just keep in mind that whenever you have a complex number plus another complex number, I'm going to add the real parts and I'm going to add the imaginary parts, and that's your solution. With subtracting over here, it's really the same idea. I'm just going to start though, depending on how you were taught to think of this. I always think of that minus in front of the parentheses as distributing a negative 1. So that's going to make that a negative 6 plus 7i. And then I have negative 4 plus 3i. We don't really need our parentheses here. I could copy down the parentheses if I wanted them. But now what I'm just looking at is we're doing the same thing as the last problem. I'm going to add the real part of each number, and that's going to become a negative 10. And then I'm going to add the imaginary part of each number, and that's going to be 10i. Okay? So it's really just like your Algebra 1 combining like terms. Let's look at how to multiply complex numbers. And so what I'm going to do is this is really, you can think of this as just a binomial times another binomial. So think about, once again, your Algebra 1. So I'm going to distribute, you may have called this FOIL in the past, but I'm going to distribute. So we have 2 times 3i would become 6i. 2 times 7 would be 14. And I'm going to do this next part in red. Negative I times 3i is going to become negative 3, and then I times I is I squared. That's going to have us do something a little weird here in a minute, but that's okay. And then negative I times 7 would be negative 7i. At this point, you probably see, okay, we got a couple of like terms that we can combine. I look at my 6i, and then I take away 7i. Those two, when I combine them, we're going to leave us with negative 1i. Then you still have your 14, but then we have this negative 3i squared. Well, if you would, we need to recall that I equals the root of negative 1. So if you have I squared, that's the root of negative 1 squared. And hopefully you remember that to square and to square root are inverse operations. In other words, that's just going to kind of undo each other and just leave you with I squared equals negative 1. And this is almost an important little fact that you need to know. Just like we know the definition of I is that I equals the root of negative 1, we need to also know that I squared equals negative 1. And so why that's important is, let me just copy down what we have. So I've got my negative 1i plus 14, and then I have minus 3, but instead of I, we've now got our new little, or excuse me, instead of I squared, we know that we've got I squared equals negative 1. And if I simplify negative 3 times negative 1, that's going to be a positive 3. And then you've got a couple of like terms right here that you can combine. So I have negative 1i plus 17. Okay? Now, let's do the same thing over here with this next problem. Now I'm really multiplying 3 values. I kind of got a monomial out front, a binomial, and a binomial. And so you just got to think, whenever you normally multiply numbers, you just pick 2 and multiply them first. Then whatever you get, you multiply by the other one. So I'm going to start by taking my 3i, and I'm going to distribute it into this first parentheses. So whenever I look at this, I'm going to distribute in. We have 3i squared minus 21i. And then I'm still got my 2i plus 3 over here. And now we're ready to distribute. So if I do this, 3i squared times 2i, well, that would give us 6i cubed. And then if we do 3i squared times 3, that would give us 9i squared. Now let's do the same thing down here. We have negative 21i times 2i. That would be negative 42, and then I times I is I squared. and then negative 21i times 3, that'd be negative 62i. Now, little simplification we can do. Hopefully you remember what we know about I squared, okay? What we know about I squared is that I squared is just a negative 1. So I have 9 times negative 1 minus 42 times negative 1. I'm just going to bring down my 62i, but then I'm going to rewrite this because I want us to see something with this 6i cubed. We know that 6i cubed is, that's the same thing as 6i squared times I, or times I to the first, however you want to think of that. And then if you see that 6i squared, hopefully you're looking at that and you're thinking, okay, well that I squared, that's really just the same thing as our negative 1. And I've kind of rewritten a bunch of this. Let's kind of consolidate and simplify. So right here, we have negative 6i, because 6 times negative 1 is negative 6. We have minus 9, because 9 times negative 1 is negative 9. We have plus 42. And then lastly, we just have our minus 62i. From this point, we can combine our like terms. I have negative 68i. And then right here we have 42 take away 9. What would that be? 33 for these two terms. And that would be your answer for those. So the multiplying, just to kind of summarize what we just did, we're going to multiply just like regular binomials like we've been doing since Algebra 1. But your thing that you got to be careful about is when you end up with that I squared, we got to substitute out for a negative 1, because often it will turn these terms with I squareds back into constants. You can see it happen right there. You can see it happen right there. You can see it happen right there. Now, let's look at dividing complex numbers. And this will be, I think this is our last slide. Yeah, we'll stop after this. I'm not going to go into that next part. So right here, we have 3 plus 2i over 5 minus I. It's not considered simplified if we leave an I in the denominator. If we leave our denominator as imaginary or complex, that is not considered simplified. And so what we're going to do is we want to rewrite this number in an equivalent form that does not have an I in the denominator. And so let's start with B. I think B is going to be an easier example. So if I start over here, I got to think, okay, well if I multiply this by 1, okay, and we're going to multiply this by some form, I always call it a fancy one, because anything over itself is just multiplying by 1, and then anything times 1 would just be itself. So we're going to rewrite this in a different form via multiplying by 1. And what we're going to do here is I'm going to multiply by I over I, because I over I is 1. And then when I multiply straight across, I have 3i in the numerator, but my denominator becomes I squared. And if we remember from the last slide, hopefully you're seeing that and you're thinking, I see what we're doing here, because we know that I squared equals negative 1. And so then what we're left with is we're left with 3i over negative 1, but 3i over negative 1 is just negative 3i. So weirdly enough, this is the same thing as this. Okay, it's just in a different form. Now let's look at this example over here, because this one's a little bit trickier. What we do here is we multiply by something, and I'm going to write it over here to the side. We multiply something that we call the complex conjugate. And what that means is instead of just multiplying by I over I here, we're going to kind of change the sign on our denominator here. In other words, instead of multiplying by 5 minus I over 5 minus I, what we're going to do is we're going to multiply by 5 plus I over 5 plus I. So I'm going to take whatever this binomial is in the denominator. If it's subtraction, I'm going to change it to addition. If it's addition right there, I'm going to change it to subtraction. And then hopefully what you see is here in a minute, we're about to multiply this all out, and it's going to cancel really nicely. Okay, so let's just kind of work on that real quick. I'm worried I might run out of space, but let's try it anyways. So starting off with my distribution in the numerator, we should have 15 plus 3i plus, and then these two right here, 2i times 5 would be 10i. And then lastly, we have 2i times I, which is 2i squared. That's this term times this term. So we're just doing a FOIL or a distribution in our numerator. And let's come down to the denominator and do the same thing. So I'm going to do 5 times 5, which is 25. Then I'm going to do 5 times I, which is plus 5I. And here's where these opposite signs come into handy, because now I'm going to do negative I times 5, which is negative 5I. And hopefully you already seen right there, those are going to cancel here in a minute. But then negative I times I would be negative I squared. But remember, our entire goal is to get the i's, the imaginary numbers, out of the denominator. And look how nicely this did that, because that's going to cancel. And then we know that this is going to turn into a constant. So let's kind of copy down what we have so far. I'm going to copy it straight down. So we have 15, but then the 3i and 10i are like terms. And then 2i squared is 2 times negative 1, because our I is a negative 1. I've been doing that in red in this video, so I'll keep that there. And then in our denominator, we have 25. Those canceled. And then we're left with minus I squared. And by doing this, by creating the I squared, by creating the opposite signs here with our complex conjugate, we turned this into an expression that has a constant in the denominator. There's no imaginary numbers in the denominator. So let's simplify one last time and then we'll be done. 15 minus 2, because this becomes a negative 2. 15 minus 2 would be 13, and then we still have our 13i. And then our denominator becomes 25, and then this becomes a plus 1. If you really wanted to simplify, 13 over 26 is 1/2. And then 13i over 26 is going to be I over 2, or 1i over 2. You could write it like that or like that.